Chemistry DK014 Discussion Tutorial Chapter 6 Periodic Table Subtopic 6.2 Periodicity. Today we focus on learning outcome C, define electronegativity, learning outcome D, explain variation in electronegativity across period and down the group. Learning outcome E, define the first ionization energy. Learning outcome F, explain the variation in first ionization energy across period down the group. Before this, we have learned about the trend of atomic radius in periodic table. Remember, across period from left to right, the atomic radius decrease. In other words, the size of atoms are getting smaller. This is due to increase in effective nuclear charge ZF. Down the group from top to bottom, the atomic radius increase. In other words, the size of atoms are getting bigger. This is due to greater shielding effect. Next, we learn about comparison between the size of ion and its parent atom. Generally, positive ion is smaller than its parent atom and negative ion is bigger than its parent atom. This is due to electron-electron repulsion. Question 2a. What is effective nuclear charge ZF? ZF describes the net positive charge felt by an outermost electron. ZF menerangkan tentang keseluruhan charge positif yang dirasai oleh elektron di petala paling hujung. The formula of ZF is Z minus S. Z represents proton number, S represents inner electrons. Question 2b. Explain the trend of atomic radii across a period in the periodic table. First, across period from left to right, the proton number increase. Next, the effective nuclear charge ZF also increase. However, the number of shells and inner electrons remain the same. Next, attraction between nucleus and outer electron become stronger. Next, outer electrons are pulled closer to the nucleus. Finally, atomic size decreases across period. 5a. Define the term electronegativity. Berikan maksud bagi istilah electronegativity. Electronegativity refers to tendency for an atom to attract electrons to itself when it is chemically combined with another element. Electronegativity merujuk kepada kecenderungan bagi suatu atom untuk menarik elektron ke arahnya apabila ia bergabung secara tindak balas kimia dengan unsur yang lain. This diagram shows this situation of electronegativity. Let's say this is atom that attract electrons to itself. As for example, the molecule of hydrogen fluoride. Hydrogen fluoride consists of one single covalent bond. Based on periodic table, hydrogen is electropositive atom with partially positive charge and fluorine atom is electronegative atom with partially negative charge. Fluorine will attract electron to itself, and that's why fluorine has bigger electron cloud compared to the hydrogen. This is the periodic table and the value of electronegativity. The maximum value is 4.0, which is belong to fluorine. Fluorine is the most electronegative atom in periodic table. And there are also other elements such as oxygen and nitrogen. These three atoms are example of elements with higher electronegativity in periodic table. Next is relationship between electronegativity and the size of atom. Smaller atom versus bigger atom. Smaller atom has stronger attraction between nucleus and outer electron. That's why small atom has higher tendency to attract electron to itself. Thus, it has higher electronegativity. Meanwhile, bigger atom has weaker attraction between nucleus and outer electron. Thus, it has lower tendency to attract electron to itself. So, it has lower electronegativity. Explain qualitatively the variation of electronegativity down a group. Down the group from top to bottom, the number of shell or energy level and increase. Number of inner electron increase. Shielding effect greater. Attraction between nucleus and outer electron become weaker. Atomic size increase down group. Tendency to attract electron decrease. Finally, electronegativity decrease. Jadi, menuruni kumpulan dari atas ke bawah, kita tengok contoh kumpulan 1 daripada lithium sehinggalah potasium. Apa yang kita dapati, saiz atom semakin besar menuruni kumpulan. Ini bermaksud daya tarikan antara nukleus dan outer elektron adalah lemah. Apabila daya tarikan tersebut lemah, ini bermaksud atom tersebut tidak kuat menarik elektron ke arahnya. Oleh itu, electronegativity akan berkurang. Dalam situasi kumpulan 1, potasium mempunyai electronegativity yang paling rendah berbanding sodium dan lithium. Question 5C. Why does the electronegativity of the elements increase across a period? Across period from left to right, the proton number increase. The effective nuclear charge, ZF, also increase. Attraction between nucleus and outer electron become stronger. Atomic size decreases across period. Tendency to attract electron increase. Finally, electronegativity increase. Jadi, kita tengok trend electronegativity merentasi color 2 daripada lithium sehinggalah kepada neon. Apa yang kita dapati, saiz atom semakin kecil. Hal ini kerana daya tarikan antara nukleus dan outer elektron adalah kuat. Oleh itu, merentasi color, atom semakin kuat menarik elektron ke arahnya. Oleh itu, electronegativity akan meningkat. Question 3A. Define the term first ionization energy. It refers to minimum energy required to remove 1 mole of electrons from 1 mole of gaseous atoms in its ground state. Tenaga pengayunan pertama merujuk kepada jumlah tenaga minimum yang diperlukan untuk proses buang elektron. Buang elektron sebanyak 1 mol. Buang elektron daripada siapa? Buang daripada atom. Atom tersebut juga sebanyak 1 mol dan dalam fasa gas. Ingat semula, 1 mol merujuk kepada nombor Avogadro iaitu sebanyak 6.02 darab 10 kuasa 23. Unit bagi ionization energy adalah joule per mole ataupun kilojoule per mole. Example, 1 mole of sodium atom in gaseous state remove 1 mole of electron to produce 1 mole of sodium ion also in gaseous state. The energy involved for this process known as first ionization energy. Question 3B. Discuss the trend of ionization energy of elements across a period. Across period from left to right, the proton number increase. The effective nuclear charge also increase. Attraction between nucleus and outer electron become stronger. Atomic size decrease across period. More energy required to remove electron. Finally, ionization energy increase. Okey, apabila merentasi color, apa yang kita faham, saiz semakin mengecil disebabkan daya tarikan antara nukleus dan outer elektron semakin kuat. Oleh itu, proses untuk buang elektron adalah sukar. Apabila proses tersebut sukar, maka banyak tenaga yang diperlukan untuk membuang elektron tersebut. Oleh itu, tenaga pengayunan akan meningkat. Question 3b. Discuss the trend of ionization energy of elements down group. Down the group from top to bottom, the number of shell or energy level n increase. Number of inner electron increase, shielding effect greater, attraction between nucleus and outer electron weaker, atomic size increase down group, less energy required to remove electron. Finally, ionization energy decrease. Baiklah, menuruni kumpulan dari atas ke bawah, apa yang kita dapati, saiz atom semakin besar. Ini disebabkan daya tarikan antara nukleus dan outer elektron semakin lemah. Oleh itu, proses untuk buang elektron adalah mudah. Maka, kurang tenaga yang diperlukan untuk membuang elektron tersebut. Oleh itu, tenaga pengayunan berkurang. Question 4. Given electronic configuration for elements P and Q, explain the difference in the first ionization energy between P and Q. Diberikan electronic configuration bagi unsur P dan Q, jelaskan perbezaan bagi tenaga pengayunan pertama di antara P dan Q. First, students need to identify the position of P and Q in the periodic table. Based on their electronic configuration, both P and Q have same highest energy level, which is 3. It means that P and Q in the same period. Next, where is the position of P and Q? Which one on the left side and which one on the right side? Based on the valence electron configuration P3s1, thus P is group 1. Based on valence electron configuration of Q 3s2 3p4, Q is group 16. Thus, the position is P on the left side of period 3 and Q on the right side. Across period 3, from P to Q, effective nuclear charge increase. It means that Q is smaller than P. Thus, attraction between nucleus and outer electron is stronger in Q compared to P. It is more difficult to remove electron in Q, and more energy is required than in P. Finally, the first ionization energy of Q is higher than P. Summary. Across period, atomic radius decrease, proton number increase, effective nuclear charge increase, attraction between nucleus and outer electron increase. That's why the outer electron are pulled closer to the nucleus and atomic size smaller. The stronger attraction makes electronegativity higher and ionization energy also higher because the process to remove electron is quite difficult and more energy required to remove that electrons. Down the group from top to bottom, atomic radius increase because the number of shells or energy level increase, the number of inner electron increase, and greater shielding effect. It makes the attraction between the nucleus and outer electrons weaker, and the outer electron are farther from the nucleus and makes the atomic size bigger. The weaker attraction makes electronegativity lower and ionization energy also lower, i.e. lower because the process to remove electron is quite easy. That's why less energy required to remove the electron. In conclusion, across period from left to right, the atomic size smaller. Down the group from top to bottom, the atomic size bigger. End of slide. Thank you.